including myself and including yours as well. Okay, so today is an important chapter because we will learn how to do block and process flow diagram. So this is the most important part of your design, and without this, you cannot actually complete your part 1 of your project. Okay, so we will learn how do we do block and process flow diagram. You have to understand block dengan process flow diagram ni has certain rules and regulation and standard, and you have to follow. So this block and process flow diagram, you cannot simply, especially process flow diagram. Block is not that hard. Block is quite straightforward. Tapi process flow diagram ni kena ada a lot of rules and to it that you have to follow because it's a standard that semua orang kalau baca your process flow diagram, they should be able to understand your process flow diagram. Okay, so process flow diagram ada basically, diagram basically has 3 level. So in design project 1, you will learn level 1, level 2, which is block flow diagram, process flow diagram, level 1, level 2. Then in design project 2, you will do PNID, piping and instrumentation diagram. Okay, so for design project 1, you are supposed to come up with block flow diagram, process flow diagram. As you can see from the slide, it becomes difficult as you go to the levels, and of course PNID will be the most complex one. Okay, so nak memahami, but we always start with block diagram, we go to flow diagram, then we go to PNID diagram. Okay, so first of all, we go to block flow diagram, BFD, or sometimes we just call it as block diagram. Okay, so block diagram ni sebenarnya very simple. Dia macam kamu buat untuk mass balance kan, you have box. So it's to show an overall processing picture of a chemical process to screen potential process alternative. Kenapa dia kata macam tu? Sebab basically setiap one box is to represent one major equipment. So major equipment tu boleh jadi separator, distillation column, reactor, vacuum column, so on and so forth. It only encompasses the main equipment. So means pump, compressor, heat exchanger, how do I say, the common ones are not included in your block diagram. Block diagram hanya main equipment. Okay, so this can be the starting point to develop PFD. Sebab tu, from the block diagram, you can already predict how complex your plant will be. Example, in this case, you can see there are 5 boxes, right? So it tells us that we will have 5 main equipment. So then you include the auxiliary ones. Sebagai contohnya, you include like tell you pump, compressor, expander, heat exchanger, so on and so forth. Then this will also, then you will have the overall process flow diagram. Itu akan menjadi process flow diagram. So block diagram hanya main equipment, and even that pun equipment tu dalam bentuk kotak-kotak. So each box is actually to represent one process. Kita tak namakan block box tu berdasarkan equipment. Kita namakan box tu berdasarkan proses dia. Contohnya, for example, in this case, the first box to represent chlorination. So maknanya tindak baras chlorination. Second one is oxychlorination, another process, oxychlorination. Third, purification. So kita tak letak distillation column, kita letak purification. Sebab at this stage, kita belum decide what type of equipment you want to use. Sebab purification ada banyak jenis. You can use a lot different types of separation equipment. So at block diagram, kita tak state equipment tu, kita state process tu. So purification. Next, cracking. So cracking pun dia adalah proses dia. Tapi equipment untuk cracking tu can be different type of equipment which we haven't decide yet. Next, another purification. So for your case juga later, you have to do this. You have to identify your main process. Sebenarnya semalam daripada consultation with the 3 groups, I think 3 of the groups somewhat had the block diagram, tapi itu daripada literature kan. So you have to do your own block diagram for your process. So for example, macam one group, we decided to cut an equipment out from that part, or another group, kita decided to cut out one stage. So itu daripada literature. So from the literature, after you have already decided what you want to modify, make sure you can come up with your own block diagram based on what you have already discussed with me and what you want to modify from the literature one. So you can either cut or you want to add pun boleh, but from the discussion yesterday, I think the groups decided to cut off certain equipment, certain groups decided to cut off certain process. That one is fine, because or else it becomes a little bit more complex if you do not do that. Okay, so the block diagram is really depends on your group discussion that we had yesterday, and we're going to have again next week. Okay, so first of all, as I say, dia punya rules for block diagram. First, operation shown by block. So satu kotak mewakili satu operation. Let's say kamu kata the first one is chlorination. Okay, satu proses. Macam contoh semalam saya rasa I cannot remember. One is purification of methanol. Okay, methanol purification. Dimethyl ether purification. So satu kolom tu satu kotak kan, satu kotak tu mewakili satu kolom kan, satu kotak ni methanol purification. Masuk kepada kotak kedua, kolom yang kedua, dimethyl ether purification. Kotak ketiga baru phenol, something like that purification. So kotak mewakili satu equipment itu. Okay. Then the line shown with arrow. So the line kamu kena tunjuk anak panah kat penghujung dia is at the end. So anak panah tak payah buat pada dia, hanya anak panah yang masuk. Keluar tak payah ada anak panah. The anak panah is to indicate, the arrow indicate kotak mana yang dia masuk. Example like this, you can see kotak yang masuk goes to reaction. Got the sign. Nak keluar pun kena tunjuk. Maksudnya the arrow goes towards, let's say the steam goes towards up. So the anak panah is always towards entering something for the block flow diagram. Okay, so ada anak panah. Third, flow dia mesti sentiasa, even PFD pun sama, left to right whenever possible. Kalau possible, proses kita sentiasa bermula daripada kiri ke kanan. Left to right. Unless ada kes yang akan balik dari kanan ke kiri if you have recycle. Example this case, you see this one is from right to left because they have recycle. That's the exception. Kalau tak ada recycle, most of the time it goes from left to right. Maksudnya proses kamu, pembacaan proses kamu akan bermula daripada kiri ke kanan. Jangan terbalik kanan ke kiri lah, atas ke bawah ke, tak boleh. It's always left to right unless you have recycle stream. Okay, next. Light stream towards top, heavy stream towards bottom. Okay, ini adalah bermaksud apabila you have purification or separation. For example, separation, okay, contohnya case absorption ni, separation kan, okay. So, dia akan ada top product, bottom product. Erti kata yang senang, kamu imagine, katakanlah this separation, dia memisahkan mengikut fasa. So, you have vapor, you have liquid. So, vapor ringan kan, so vapor top product. Liquid tu heavy kan, bottom product. So whatever is in vapor form or is in the lighter form goes to the top, which is the heavier form goes to the bottom. So let's say your separation is liquid solid. Of course liquid lebih ringan kan, liquid top product, solid bottom product. Okay, so that's the concept. Light one goes to the top, heavy one goes to the bottom. So nanti bila kamu tengok daripada literature pun, PFD daripada literature, kalau kamu tengok benda tu keluar ke atas, most likely dia adalah, kalau lah dia macam distillation mesti vapor liquid. Yang keluar ke atas tu mesti vapor, yang keluar bawah tu liquid. So you can already predict, ataupun kalau kes pemisahan gas dengan cecair, gas and liquid, right? So let's say for certain case, dia guna syngas. So syngas got COH2, dia nak separate from methanol. So naturally COH2 gas will be the top product. Methanol, the liquid will go at the bottom, will go out from the bottom. So, kamu dah boleh agak yang keluar atas tu mesti gas, mesti vapor, yang kat bawah tu mestilah liquid. Okay, that's next. Next, critical information unique to the process supplied. Okay, and then next, if the line cross horizontal line is continuous. This one I will explain nanti dalam PFD, saya akan tunjuk contoh. Macam mana kamu nak buat kalau you have line that cross to each other. Means kamu ada horizontal line, kamu ada vertical line. Bagaimana kamu nak make sure line tu tak boleh cross each other. Satu line tu kena putus. So I will tell you later what does this mean when we are doing PFD. Sebab konsep yang sama juga untuk PFD. Okay, so this is an example of a block flow diagram from your, I think this from your seniors. So kamu tengok proses dia bermula dengan first dia pre-treatment dulu, dia crush and grind dulu. I think this one is production of phosphoric acid. So first part dia preparation, raw material preparation, dia crushing dengan grinding dulu. Then they go to the second one. So first kotak tu equipment dia apa? Crusher lah. Then go to the second one, reaction. So equipment dia reactor. So they have reaction. Goes to the third one, separation. So depends lah what separation equipment that you want to use. So for the separation, okay, some the top mungkin dia separate top dengan bottom. Top one goes to absorption, the bottom one goes to filtration. Sebab I think the bottom one is solid liquid. The top one is I think a vapor mixture. So the vapor mixture they absorb. The liquid mixture goes to liquid solid mixture goes to filtration. They filter out the solid. The liquid goes to separation and then eventually evaporation to increase the purity of the product. So dalam block flow diagram ni basically akan ada 1, 2, 3, 4, 7 main equipments and plus auxiliary equipments. This will go up to maybe 10 to 15 equipment. So block diagram ni senang je, not as difficult as process flow diagram. So this can be done quite fast. Okay, so homework untuk minggu depan, saya beritahu dulu sekarang, homework untuk minggu depan, you must already at least come up with the block diagram untuk proses yang kita dah bincang semalam. The one that we have already discussed and agree upon, proses yang kamu dah pilih, please now prepare the block diagram for it, for me to see next week. Okay, so block diagram tu dah wajib kena buat by next week untuk proses yang kita pilih. Okay, so as I told you, kamu tak payah prepare slide, kamu buat dalam Microsoft Word pun tak apa. Untuk block diagram, you can use Microsoft Word. You want to do in PowerPoint pun boleh, but you just show me the block diagram. Okay, you can do this is the best one, tunjuk diagram. Letak juga apa yang masuk dan keluar untuk setiap kotak itu supaya kita boleh faham proses dia. Contoh dalam kes ni, okay, crushing, grinding, phosphate rock dengan phosphoric acid. Okay, dalam reaction, ditambah sulfuric acid. Tindak balas berlaku equals to separation, so on and so forth. So this is quite a good example. I want you to do something like this for the process that you have chosen for our next week consultation. Okay, right. So that's the homework for next week untuk consultation. Okay, ada lagi tambah lagi homework ni saya beritahu. Okay. So done on block diagram, that's quite straightforward, quite easy. The one that will be a little bit difficult is on process flow diagram. So process flow diagram ni lah sebenarnya we cause a lot of headache. But I see from yesterday punya consultation, I think 2 groups dah ada quite good reference from literature which you can start from. Okay, so tak apa, that's good. Just that setempat tu kamu kena modify sikit lah. One group saya rasa dia tak dapat lagi tapi dia dah faham apa yang dia kena buat. So you should have a good process flow diagram. Kata apa, kalau group yang tak sure tu, you can ask the other 2 group, the one that they show me, that one should be quite sufficiently enough untuk kamu buat kamu punya process flow diagram. Remember, you have to do your own process flow diagram. Okay, and don't forget, I already shared with everybody the link to the Microsoft Visio. You will use Microsoft Visio to do your process flow diagram, but it's not compulsory. You want to use any other software pun boleh, tapi Microsoft Visio dah ada simbol untuk equipment tu yang I will show you later. Sebab tu saya suruh guna Visio sebab dah ada equipment tu punya simbol, so it be easier. But there are other software as well yang dah ada pun sebenarnya, so it's up to you. I will not force, but I gave you the installer for the Microsoft Visio. That one is under UniKL license. It's a license yang boleh access kat luar, so you can download the installer into your computer. If you have any problem installing it, you can inform me, but should be no problem lah. Senior kamu lepas pun dia guna installer yang sama daripada link yang sama. Okay, now let me go to process flow diagram. So process flow diagram is more complicated because now dia dah include equipment. Tadi just kotak untuk mewakili operation, but for process flow diagram dah mewakili, you already have the equipment. One. Second, equipment ni dah ada nama dan number. You have to name and number, and this name and number is not just sesuka hati. You have a certain rules and standard juga bila nak namakan dia dan juga nak numberkan dia. One. Second, it become complicated sebab sekarang kamu dah kena include all the process flow stream. Ataupun kata lain, setiap part line tu dah ada dalam proses flow diagram kamu. Kamu dah kena pasti setiap part line dalam proses flow diagram kamu, and each this streamline will have its own number. So setiap stream ni ada nombor dia sendiri. Kamu imagine part line ni nombor 1, part line seterusnya nombor 2, so on and so forth. So you cannot have more than one part line with the same number. Different part line, different number. 2. Okay, so that becomes a little bit more complex. Third, Utility stream pun dah masuk. So if you're using compressed air, you're using gas, you're using steam, you're using hot water, cooling water for your heat exchanger, you also have to include in your PFD for the major equipment. So later I will show you apa maksud dia utility stream yang kita kena letak. Then next, kamu kena letak juga temperature dan pressure. So that also become a complex thing sebab kena masuk temperature dan pressure sekali. Okay, so let me show you first one by one how to understand a process flow diagram and how you're going to draw the process flow diagram. So this is an example of a process flow diagram. From again nak baca daripada left to right, meaning your raw material is toluene and hydrogen. Your final product is actually benzene. Okay, so first, equipment are identified by number and a label name above the PFD. So dalam PFD kamu, kat atas ni adalah all of your equipment, name and the numbering. Okay, so example dalam kes ni ada toluene storage drum, toluene feed pump, feed preheater, feed heater, reactor, so on and so forth, compressor, condenser, column, pump, so on and so forth. Dah ada semua, keseluruhan equipment termasuk auxiliary equipment dah kena ada. Kalau ada 5 heat exchanger, semua heat exchanger pun kena masuk dalam list. Ada 5 pump, semua pump pun kena masuk dalam list. Okay, so one thing. Okay, next one. You have to see, kena faham certain rules. Okay, first, kamu tengok process input, okay, you have your raw material, right? Your raw material will be labeled as a circle dengan on the left hand side, half of the left hand side circle is blackened, is darkened to indicate yang dia masuk. Okay, dia adalah bulat dengan separuh daripada bulat tu dihitamkan untuk indicate dia adalah raw material yang masuk ke dalam sistem. So for example, if your case you're using syngas, CO2 and H2, so kamu akan letak CO2, H2, lukis bulat, hitamkan separuh pada belah kiri, people will understand that's your input, your raw material. So if you have, katakan raw material kamu campuran, is a mixture, you purchase from your supplier, is already a mixture, satu sahajalah kamu punya hitam tu, bulat tu. If you are using 2 separate raw material, so you have another one. Example this case, hydrogen. Hydrogen is the second raw material. So hydrogen start at the bottom. So hydrogen pun sama, one circle, half of the circle is darkened to indicate this is the second input to your system, which is your hydrogen gas. Okay, so this is only for raw material. Next, kalau kiri bermula dengan proses input, kat kanan dia berakhir dengan proses output. What is your end product? So, for example, phenol, methanol, sulfuric acid, that will be your final product, process output. So, you have here, apa beza dia sekarang? Kamu tengok dia adalah masih circle, tapi sekarang bahagian kanan circle tu dihitamkan. So this is gas, down is the benzene, I think it's the production of benzene. So kesemua produk including byproduct must have this as well. So you see benzene, the main product, so bulat dihitamkan di belah kanan to indicate this is your process output or your product. So your PFD at the end tu mestilah ada satu bulatan untuk indicate methanol ke, phenol ke, sulfuric acid ke, so on and so forth. Okay, so that's for process input, process output. Okay, so I hope you really take this into account. Nanti PFD nanti nak buat benda ni kena ada. So if you do this salah tak buat ni, nanti kamu tak dapat markah lah, kena potong markah part ni. Okay, so first. Second is kamu kena tunjuk, okay, process input, process output. Third, dah kena ada WAF in your PFD. Example this. So WAF tu dah ada, kena ada. Example this WAF. You can see there are various WAF in the system. So this one pun kamu kena ada untuk indicate dalam PFD kamu tu kat mana yang kamu akan ada WAF. Okay, tak apa. Part WAF ni nanti kemudian, okay, bila kamu start buat PFD, biasanya WAF ni adalah benda yang last kali kita buat. Sebab kita kena establish dulu part streamline. Lepas kita dah establish streamline, baru kita akan tengok mana kita nak letak WAF, so on and so forth. So WAF tu part kemudian. Okay, next. Stream number. Okay, so kamu perasan setiap equipment is connected by a streamline, or kamu just imagine dia adalah pipeline. So dia adalah pipeline untuk connect to each of the equipment, and pipeline tu mesti ada anak panah yang masuk. Kamu tak boleh buat line tanpa anak panah sebab dan kita tak tahu dia menghala ke arah mana. So the anak panah must go towards entering an equipment. Example, contohnya kamu tengok dalam kes V101 ni, so toluene goes into V101. You can see hydrogen, not hydrogen, recycle from stream 11 akan masuk kepada V101. If you see here, kamu tengok ada anak panah masuk kepada V101, right? You look that is actually yang di recycle daripada stream 11 will be goes into the V101. So setiap line mesti ada arrow sebab untuk indicate dia masuk ke mana, dan setiap line kena ada number. Every line must have its number sebab nanti in part 2 of your design project minggu ke-8 onwards, setiap pipeline ni kamu kena buat material balance. Kamu kena tahu untuk setiap pipeline ni, streamline ni, berapa molar flow rate untuk setiap bahan yang ada dalam pipeline itu. So kalau imagine setiap pipeline tu, katakan liquid, dalam liquid tu ada apa? Molar flow rate dia kamu kena kira untuk setiap pipeline. Sebab tu you have to number all the pipeline in the PFD. So we call it as stream number. So that's number 4. Number 5. Satu juga kesusahan dia, untuk setiap streamline atau pipeline kena tahu pressure and temperature. This is for your energy balance. Okay, kalaupun mungkin dia depend sebab this is also the biggest challenge sebab dalam literature susah sebenarnya kita tak dapat untuk tahu untuk setiap streamline. So normally from literature, you will know the main one. Macam reactor kamu boleh tahu. Macam column kita boleh tahu. So yang selebihnya, sometimes we need to do our own initial prediction. Which that's why consultation is needed. Because normally I will ask my student, cari dulu part yang penting. Dan yang selebihnya kita akan discuss untuk tengok what should be the pressure and temperature. But right, that's your task, okay, but during consultation we will discuss sebab by right semua stream ni kena ada pressure dengan temperature. Kenapa? Sebab kamu nak buat energy balance. So without knowing temperature and pressure, you will not know which unit yang memerlukan pengiraan energy balance. Okay, so for example, let's say this heater. Kalau kamu tak tahu temperature pressure, jadi kita nak kira Q. Kita kena kira heat kan? So kita nak kira Q untuk heater ni, kita kena tahu berapa temperature, berapa pressure yang masuk, berapa temperature pressure yang keluar. So that one also become a problem. Tapi tu part yang seterusnya. So by right, tu yang jadi masalah sebab masa presentation minggu 6, kamu dah kena ada semua ni. So that's why it become a little bit stress on my side juga sebab we are really running out of time. So presentation 1 might have a little bit difficulty yang kamu kena betul-betul pulung buat lah untuk presentation 1. Okay. The most also I can delay to week 7. Tapi let's see how because this presentation is not evaluated by me, evaluated by independent assessor, lecturer lain. So saya kena check dengan lecturer lain bila masa dia boleh attend presentation. The most we can postpone to week 7, but we cannot go more than week 7 for the presentation. And if we go presentation week 7, masa study week tu lah kamu kena hantar report. So macam that's the part. Kalau let's discuss later as we go to the progress. Nanti kita tengok macam mana. Okay? Right. So sebab kalau saya paksa kamu buat presentation minggu 6 pun, kamu tak ready, kamu dapat markah rendah pun macam not fair jugalah. So kita tengok macam mana later, but the most you can go pun presentation minggu 7. Report maybe I can delay until kamu naik sem break. Mungkin I can delay until kamu naik sem break. Means masa sem break tu kamu prepare report. Okay, but we will see as we go on. Okay, on tentatively is still week 6. Okay. So temperature and pressure is the next thing yang kita kena discuss. So by right, okay, normally PFD ni to be honest kalau dengan senior-senior kamu, PFD nak finalize pun dah 2 minggu tu kira very impossible. 2 minggu tu kira kalau dapat memang hebat lah. Normally it's 3 to 4 weeks untuk finalize PFD. Tapi kamu tengok ni dah minggu ketiga kan, minggu depan minggu keempat kan dah. So you actually have about 2 weeks to finalize the entire PFD. So that's also a challenge lah. Okay, so temperature and pressure ni kita akan discuss later once the PFD is settled. Okay, so temperature pressure ni kamu tak payah bimbang dulu. Tapi if you want to divide the job, okay, sebab kamu for the PFD dengan block, everybody has to work together, right? So maybe you assign yourself, this is upper recommendation, one person is for the drawing, okay, so seorang ni je buat drawing, okay, yang lagi seorang ni, your task is to find all the condition, temperature, pressure untuk semua condition, okay, the other two is to finalize the equipment, dia punya sequence, dia punya stream number tu, kamu kena finalize, then bagi kepada orang yang nak draw tu. Sebab yang draw itu bukan senang, sebab nanti dia kena adjust lagi a lot of things. Okay, so that's how I advise you on how to distribute the job. Okay, so that's why I say design, you cannot have sleeping partners. Kalau seorang sleep, memang yang ketiga lagi adalah will have a lot of problem for the other three. Kalau if 1 or 2 member yang sleep, it will be very hard for the others to pick up the work. Okay, so next, done. Next. Utility stream, as I told you, right? PFD become complex sebab sekarang kamu kena masuk utility stream. For example, we have this heat exchanger. Okay, this is actually a reboiler. So reboiler menggunakan MPS, medium pressure steam. Okay, then sometimes they use LPS. This is low pressure steam. Then sometimes you see heat exchanger ada cooling water. So this is a cooler. They use the utilities cooling water. Apa lagi? Here, heat exchanger again. High pressure steam. So utility yang digunakan, baik digunakan untuk memanaskan dia, diguna steam. So dia ada high pressure steam, low pressure steam, medium pressure steam. Okay, so sometimes you use cooling water. Kalau kita nak sejukkan, kita guna cooling water. So benda ni biasanya dalam literature memang takkan ada. So that's the problem, that's another added challenge. Kalau kamu tengok pada literature, biasanya PFD yang dibagi adalah the main equipment. Utilities ni semua kadang-kadang ada tapi most of the time tak ada. Sebab kamu kena figure out sendiri. Kalau nak gunakan katakan distillation column kan, mestilah ada reboiler dengan condenser. So mestilah ada utility yang digunakan. Contohnya macam this one is heater. I think this is a furnace. So furnace kita nak panaskan furnace, right? So diguna apa? Diguna fuel gas, digunakan fuel gas untuk panaskan dia punya heater. That is also utility. Okay, so this is example, tapi tak semua equipment ada utility. For example, if just a settling tank vessel ni tak ada utility. So it depend kalau equipment tu melibatkan perubahan suhu, pemanasan atau penyujukan, then you will use utility. You have to really determine what are the utility you will use. Okay, so that's also another added challenge. Okay, so next. First, let's talk about the equipment first. Okay, so kamu now have to identify all the main equipment, okay, major equipment, which is distillation column, reactor, and tanks. And then you have to also show minor equipment. Example, heat exchanger, pump, reactor, mixers. Okay, so major equipment, minor equipment, termasuklah compressor, pump, heat exchanger, as I told you. Okay, then common symbol found in the process flow diagram are shown. Okay, so first of all, equipment yang kamu nak pilih tu, simbol dia kamu tak boleh sebarangan pilih. Kamu tak boleh reactor, kamu nak pilih silinder lah, reactor kamu nak pilih, you cannot simply choose. There are already standard symbols for the equipment. So Visio has most of the standard equipment tu untuk chemical processing, dia dah ada simbol dia. Sebab tu Visio is easier, sebab dia dah ada, kamu yang ambil je. This is for the guideline for you, but please don't only refer to my notes. You can just Google it, okay? Process flow diagram symbol for equipment. You can just Google it. There's a lot of internet source that you can find for the symbol, okay? But the most common one that you will see, of course, is vessel, okay? Reactor, okay? Column, autoclave, stir tank reactor. Kalau reaktor kamu menggunakan stir tank reactor, CSTR, kamu akan guna ni. Kalau kamu ada tubular reactor, plug flow reactor, you will use this symbol, so on and so forth. I cannot show all. Dia banyak kan. Saya kata macam setiap plug ada equipment yang berlainan kan. So, I will show you the standard one, but you must be aware that you can readily find it easily from reference book, or you can just Google it. The keyword will be equipment symbol for chemical processing in process flow diagram. Okay, that's the keyword. I give you the keyword ready that you must use to find the equipment punya symbol. Please do not assume the symbol by yourself. Okay, no more. Next, heat exchanger. So exchanger ni common lah. You can see heat exchanger normally we will use this, the basic one. Heater, if you're using fired heater. So even heat exchanger ke equipment ni pun ada simbol yang berlainan untuk jenis equipment yang berlainan. Ada yang general or you can use the specific one. Okay, so this is for heat exchanger equipment yang tadinya punya process technology for the vessel. Next one, pump. So you have also centrifugal pump. You have compressor pump, axial or centrifugal compressor, turbine, ejector, so on and so forth. Okay, tapi tak apa if at this stage, okay, sebab biasanya dalam design project 1 part 1 ni memang banyak benda kita tak sure lagi. Okay, let's say you're not too sure what type of pump that you want to use, tak apa, guna je yang basic centrifugal pump, tak apa dulu. Nanti dalam design project part 2, as you learn more, nanti kita akan ubah lagi lah PFD2. PFD2 will always change according to our discussion. So akan ada version 1, version 2, version 3. By the time you submit to me, final report tu dah version 10 or what. It's very normal. So biasanya saya say assign one person yang akan draw. Tapi kerja dia draw je. Yang lain kena bagi information. Kerja dia hanya draw sebab kalau ramai orang draw pun jadi kompleks. Only one person that should be able to draw, but kerja dia hanya draw. Dia tak payah fikir. Your other member help him to figure out the things. His part is only to determine simbol apa nak guna, susunan simbol dia, size simbol dia. That will be the role of one person lah to do it. Okay, right. So this is for the pumps. Okay, next. Okay, done. So what I discussed just now, what I show you are the general one. I didn't show you for the distillation column lah, vacuum column lah, settler lah, so on and so forth. Sebab kalau nak tunjuk banyak sangat. Okay, just to tell you, ada simbol yang seragam untuk semua equipment. Make sure you check from the, either from literature, from reference book, or you may check from the Google as well. But make sure you put in the correct keyword. Okay, next. We want to name the equipment. Penamaan equipment bukan sebarangan. You have specific standard to it. Okay, so the specific standard dia akan bermula dengan format dia XX, Y, ZZ, A/B. Apa maksud XX? Apa maksud Y? Apa maksud ZZ, A/B? I will explain. First, on the XX. XX is to identify letter for the equipment classification ataupun kita nak categorizekan equipment tu bawah kelas apa. So the main class are compressor turbine. Kalau compressor turbine kita guna C. Kalau fired heater guna H. Reactor guna R. Storage tank TK. Heat exchanger E. P is for pump, T is for tower, V is for vessel. Okay, bukan saja ni aja, ada banyak lagi. So in this slide, it shows all the main classification and the alphabet to represent the classification. Kalau classification tu ada satu huruf sajalah. Contohnya reactor R sajalah. Tapi setiap equipment ada dua huruf. For example, grinder SR. Okay, so katakan kamu kata, doktor, equipment saya tu tak ada dalam list ni. You may use your alphabet, tapi alphabet kamu guna tu tak boleh dalam alphabet yang ada dalam list yang sedia ada. Tapi based on my discussion semalam, all of you choose the very common process and the equipments are common. So I can guarantee you mesti dah ada alphabet dalam record for the equipment that you want to choose in your process. Okay, so this one, you can refer to my note. I already give you the note. Please refer here for your equipment alphabet. Kamu tak boleh sebarangan pilih please follow this. So nanti saya akan check, saya akan tengok. Kalau kamu tak follow, kena potong markah lah on this part. Okay, so done. On the format ni, part yang XX tu dah settle. So kalau reactor, letaklah R. Kalau grinder tadi, SR. Okay, done on the part XX. Now part YZZ. Apa tu part YZZ? Okay. Right. So this is example. Tengok balik PFD tadi. Example dia. Vessel. Kamu tengok dia letak V for vessel. E, heat exchanger. Sebab tadi saya tengok V, saya kata vessel kan. Sebab saya tahu V tu untuk vessel. E, heat exchanger. Okay. H, fired heater. So you're using fired heater, we use H. R, always reactor. C, compressor. So kalau compressor tiba-tiba kamu letak K, tak boleh. It must always be C for compressor. P for tower. P for pump. So this is example yang saya tunjuk daripada PFD ni. Kamu tengok, dia letak pump P102 A/B. Kita faham dulu huruf yang depan tu. Compressor C101 A/B. So huruf depan tu mewakili equipment yang kamu ada dalam sistem kamu. Okay, first. Next. YZZ A/B. Apa tu? Okay. Y is to designate the area within the plant. Okay, kamu kena faham, certain chemical plant will have more than one area. If it's a really big plant, you will have more than one area. So, kamu nak identify, adakah that equipment is in area 1 or is the equipment in area 2? If it's in area 1, the Y you will put it as 1, meaning equipment tu berada di area 1. If you put 2, meaning equipment tu berada di area 2. So, kamu faham tak maksudnya? Setiap equipment tu akan ada nombor dia sendiri. Dia tak akan ada dua equipment dengan tak akan ada dua equipment with the same number system. All equipment dia macam IC. Satu equipment IC dia. So, if you put, katakan you letak pump 1, means pump tu berada di area 1. If you put pump 2, pump tu berada di area 2. Okay. So that Y is to represent the area of which the equipment is located. The ZZ is the number of the equipment in the equipment class. Maksudnya, okay, contohnya, kamu ada 2 pump dalam area 1. So become P, pump yang pertama adalah P101, means pump pertama dalam area 1. Pump yang kedua, P102, meaning pump kedua dalam area 1. So you see, although I got 2 pump in the same area, tapi 2 pump tu takkan ada nombor yang sama. One is P101, one is P102. Pump pertama, area pertama, pump kedua, area pertama. If you have pump area kedua, pump pertama, area kedua, P201, pump pertama, area kedua. Pump kedua, area kedua, P202, pump kedua, area kedua. So that to indicate the equipment is at which area, at what sequence. Penomboran dia ikut sequence proses. Kalau dia adalah pump pertama dalam proses, kan proses pada kiri ke kanan kan. Pump pertama yang jumpa pump pertama tu, pump tu adalah nombor 1. Dia jumpa pump yang kedua tu adalah pump kedua. Sequence pump, sequence equipment follows the sequence of your process. Kamu tak boleh pump yang kat belakang tu tiba-tiba jadi nombor 1, tak boleh. Kamu kena ikut from left to right as well. Next, A/B. A/B adalah bila if you have spare for that same equipment in the same unit. Contohnya, katakan pump pertama dalam area 1 tu, pump tu ada spare. Means kalau pump 1 rosak, ada spare 1 pump. So it become A/B, meaning we know there's 2 pump or there are backup pump for that 1 pump. So pump 101, A/B maksudnya pump tu ada backup unit atau parallel unit. Kadang-kadang you can run parallel as well. So if you have parallel units or you have backup units, then you put the A/B. Okay. So this is example of the numbering. You can see, let's for example, V101. So what's that? That's vessel number 1, vessel in area 1. Ataupun dia letak dia 100 lah, unit 100. Easiest one letak unit 100 lah. Unit 1 lah sebenarnya. Okay. So first vessel in unit 100. Next, let's say you put here E102. So second heat exchanger in area 1. Ataupun dekat sini unit 100. Sama je. Means area yang pertama itu adalah heat exchanger dalam area, heat exchanger yang kedua dalam area yang pertama. So you see we have E101, E102. E101 is here. E102 is here. So the first pump on the left, the first the first exchanger will get the first 101, the second exchanger will get the second 102. So kamu kena faham, cooler ke, heater ke adalah heat exchanger equipment juga. So the same je, we name it heat exchanger, we name it cooler, we name it heater. Dia masih melibatkan proses yang sama, penukaran haba. That's why it's put it as E. Mungkin kamu terfikirkan, tapi dia preheater, kenapa letak E? Preheater pun exchanger juga, penukaran haba. Cooler, kenapa cooler tak letak C, letak E? Sebab cooler is a heat exchanger equipment, penukaran haba. So it become E as well. So dari apa-apa kamu kena faham, cooler bukan C, preheater bukan P. Cooler is E, preheater is also E, heat exchanger equipment. Okay, so next one, pump. So kamu tengok pump ni, dia put P102A/B, meaning it's a second pump in area 1 with a spare. Okay, so A/B kalau ada spare. Okay, so that is on the naming and numbering of the equipment in the system. Make sure you arrange this accordingly and make sure you name it correctly. So macam saya kata, tak boleh sembarangan. Okay. Then when you name it at the top, don't forget at the equipment juga kamu kena letak. So for example, tengok vessel ni kita letak V101. Tengok kat pump ni P101A/B. Kat equipment tu pun berdekatan dengan equipment tu, kamu kena letak juga number dengan dia punya sistem number dia. Name tak payah letak vessel 103, tak letak V103, letak E106. So you have to put the number and the number in nearby to the equipment in your process flow diagram. So sebab tu yang drawing ni pun akan jadi juga masalah, sebab kamu kena susun sistem, kamu kena susun susunan dia mengikut flow process, kamu kena letak label dia. So this one you have to, everybody have to work together to do this. So siapa yang member yang pandai sikit, bukan pandai sikit lah, someone who love to do computer work, someone who's quite good at computer work, you should do this drawing lah to make it faster. Okay, so next, stream information. Okay, stream information menggunakan first of all diamond symbol located in flow line. Apa maksud dia? Maksud dia, tengok setiap stream ni kena ada number kan? The number is inside a diamond shape symbol. Okay, diamond shape symbol, dalam dia ada number to indicate nombor untuk streamline tu. Ataupun arti kata lain, kamu imagine pelan ni kan ada banyak piping kan, setiap piping tu ada nombor dia sendiri. Kamu tak boleh share, kamu tak boleh ada piping, dua piping dengan nombor yang sendiri, sebab you must understand in the plant is all fully automated kan, so kamu ada fully control. So you imagine each of the part line tu ada flow controller, ada temperature controller, pressure controller. So kamu kata kamu nak control, kamu nak monitor temperature at part line 5. So hanya ada satu part line je kamu boleh monitor. If let's say you say you have more than one part line the same number 5, how are you going to control when you have same number for the different part line? So one part line, one number. Okay, dan dalam simbol diamond, bukan bulat, bukan segi 4, bukan what, diamond shape. Dalam diamond shape tu letak number. Okay, so ni pun jadi masalah kepada yang drawing lah, sebab nanti tukar proses ataupun tukar sikit, nombor semua akan lari. So kamu kena buat all over again. So it become a little bit of headache as well. Okay, next, numerical identification, nombor dalam diamond, flow direction shown by arrow on flow line. So as I told you, kena ada arrow yang masuk. Okay, arrow keluar tak payah, arrow yang masuk tu kena ada. Dan macam block diagram juga, mostly left to right except if you have recycle stream. Ataupun kadang-kadang ke atas ke bawah, left to right, but right to left to rarely unless you got recycle stream. That's what I say. Lagi, susunan numbering stream mesti daripada kiri ke kanan mengikut proses. Means nombor 1 mesti bermula daripada kiri, nombor yang paling last bermula di kanan. Dan sebolehnya ikutlah ada sequence, ikut flow daripada kiri ke kanan. Sama macam anak panah. So tak boleh tiba-tiba nombor 1 kat depan, nombor 5 kat belakang, tiba-tiba nombor 7 kat depan balik. Tak boleh. Kita kena betul-betul boleh tengok flow tu dengan tengok daripada kiri ke kanan. You follow the numbering. Okay. Next one, yang tadi saya kata, when you have two lines intersecting one another, vertical and horizontal. Apakah maksud dia? Okay, so vertical adalah straight line. Saya kena tu confuse. Vertical straight line, horizontal line yang mendatar. Katakan kamu ada dua line mendatar dengan melintang ni yang cross one another. You must understand horizontal line yang mendatar ni adalah dominant. Means line yang mendatar ni takkan putus. Line yang vertical yang akan putus. So can you see here? Horizontal line straight. Line yang vertical tu yang akan putus. Okay, so to give way for the horizontal line. Okay, so you cannot cross it. Kamu tak boleh silangkan dia. Kamu tak boleh bagi advantage kepada vertical. Horizontal always will be the dominant lines. Okay, so you have to understand. Mungkin kamu fikir kenapalah kena buat sampai macam ni. Tapi this is the standard yang kamu kena faham your drawing. Anybody in chemical engineering must be able to understand your drawing even without you explaining it. Kalau kamu buat dengan standard yang betul, semua orang pun boleh faham dan baca. That's the concept. That's why you have to follow these rules and regulation. And kamu kena ingat, let's say you are working in the plant, someday eventually you will leave the company. So you will leave the drawing. Someone else that comes after that must be able to understand the drawing. So if you don't have enough information, okay, that will be the challenge for the next person who wants to read the drawing. Okay, then next, add arrows for change in direction or inlet of equipment. Saya told you lah, masuk kepada equipment kena ada the arrow. Okay, for example macam ni diamond symbol with numerical identification. Tengok macam nombor 6 ni dan ditutup dengan simbol diamond. Next, arrow for inlet equipment. So arrow tu untuk masuk kepada equipment kena ada arrow. Example ni tengok ada intersection kan. So intersection ni kamu tengok horizontal line tak putus, vertical line tu yang kena putus. Okay, so this is to show yang the horizontal lines are dominant. So this is the example lah when I say about horizontal line, dominant line. Block diagram pun sama, yang mendatar tak putus, yang melintang akan putus. Okay. Then the stream number left to right as much as possible. You can see here number 1, number 2, number 3, number 4, 5, 6, 7, mana 7? 7, 8, 9. Kadang-kadang ada sikit macam dia tengok jugalah sebab kadang-kadang dia kena ikut proses juga. Bukan saya kata perfectly mesti ikut kiri ke kanan. There are certain time where you might have a little bit of jumble up but that is for unavoidable reason. Tapi most of the time memang kiri ke kanan. Okay. Next one, this is the one that akan jadi masalah utama. Temperature and pressure for the process flow diagram. Okay, tak apa. Untuk design report 1, kalau tak complete semua pun tak apa lagi. Tapi bila pergi design report 2, means kalau sampai minggu 7 report 1, kalau kamu tak dapat untuk semua pun taklah teruk sangat. Bukanlah tak teruk sangat, still okay. Tapi dalam design report tu, bukanlah design report tu. By the time you start on report tu dah kena ada sebab kamu nak buat mass balance, energy balance. Tanpa ada benda ni memang tak boleh buat langsung energy balance. That's why by right setiap stream ni kena ada temperature dengan pressure. Okay, tak apa. That's why I say as we have consultation, you assign one person, satu person ni kerja dia cari je condition untuk semua stream ni. Okay, daripada literature, then after that gather first information, then lepas tu kita discuss untuk stream lain yang kita tak cukup lagi information, we have to do certain kind of assumption already. Okay, next, utility. So you remember, if you're using anything that involve heat ataupun involve cooling, mesti memerlukan utility. Kan? Macam mana kita nak panas atau sejukkan that equipment. So you have several types. So you have steam. Even steam pun ada low pressure steam, medium pressure steam, high pressure steam. So apa beza steam ni? Apa pressure steam ni? Just that pressure dia je. Berapa pressure yang kamu guna untuk steam tu. Okay, next. Cooling water. If you're using cooling water, or if you're using water, you can also use river water. Kalau kamu tak sejukkan sangat, you don't need a very cool temperature, you can also use river water. You can use electric heater. If you're using electric heat, you can using fuel gas. Kalau kamu guna furnace, you can use fuel gas. So on and so forth. Okay, so normally heat exchanger kita guna steam lah. Steam is the cheapest, the easiest one. Okay, kalau furnace biasa kita guna fuel gas lah untuk furnace. Kalau furnace nak guna electric furnace, it's going to consume a lot of energy. Okay, even utility pun By right is the second stage. Macam bukan second stage. Part pertama bila kamu nak start PFD ni, okay, kamu kena start dulu untuk draw entire diagram dulu. Dapatkan dulu entire diagram, susunan equipment tu dulu kena ada. Okay, that's the step I will teach you. First step, keluarkan, lukis dulu diagram tu untuk keseluruhan equipment yang utama. Okay. Then next, bila dah siap, tambah utility punya equipment. So kamu tengok, katakan reaktor tu cuaca dia, reaktor tu temperature tinggi, kena letak heat exchanger, mestilah kena panaskan dulu. Katakan kalau pada reaktor tu suhu dah kena turun sebab dia nak masuk kepada distillation column, kena letak satu cooler, cooling water, kena letak satu cooler untuk sejukkan dia, so on and so forth. So start first with main equipment, lepas tu kena tambah pump. Kalau mestilah ada pump, tak macam mana kamu nak pump kamu punya raw material and your product, right? Then compressor, katakan, ataupun expander, kena tengok pressure, sebab tu kena tahu condition. Kadang-kadang nak masuk reaktor, pressure kena tinggi, kena letak compressor. Tapi lepas keluar reaktor, nak masuk distillation column, takkanlah pressure kena tinggi, kena turunkan, kena masuk expander supaya increase the pressure back, so on and so forth. Lepas tu, that is the sequence that you do. Next, baru masuk patutnya temperature, pressure dengan utility tu goes together. Dah tahu temperature, pressure, baru tahu cara nak letak utility. Then next, dah settle tu baru numberkan streamline dia. Kalau kamu terus number kat awal-awal, nanti kamu tambah utility, kamu kena adjust balik streamline number. So streamline tu lepas dah adjust semua, baru tambah streamline, baru tambah stream number, lepas tu baru number and name your equipment. So by right, that's the normal sequence that people will do. Okay, so example utility as I show here, katakan you got a cooling system, this is condenser, sebab daripada column kan, okay, kamu tahu daripada column, mesti ada vapor, mesti ada liquid, right? So you have a condenser, kamu dah pernah belajar separation kan, ada condenser, ada reboiler. So kalau condenser, gunalah cooling water. Kalau reboiler, depends lah. Kalau low temperature, probably you will use medium pressure steam. Kalau very high temperature, maybe you will use lah high pressure steam, so on and so forth. Okay, so that is on the utilities. Right, next. Okay, stream information table. Okay, so patutnya dalam diagram kamu, you will have this table. However, at this stage of your design project 1, okay, you will have this stream table, tapi certain information kamu tak letak lagi sebab kamu belum buat lagi. What do I mean by that? Okay. In the stream information table, bawah PFD tu kamu satu table tau. Table tu kena ada, first of all the stream number. Means kita kena ada information untuk setiap stream itu. Ataupun imagine, satu stream tu makin satu part line kan. Kita nak tahu condition untuk setiap part line. So you have to label the part line. Okay, next, temperature and pressure. Yang ni kamu tahulah kan, sebab tu kita letak dalam PFD. And the stream information table, you must have temperature and pressure. Okay, the next one, all ni, you don't have to put first for report 1, sebab the next part is all on the mass flow rate, molar flow rate, and also on the mass flow rate, molar flow rate. Since you haven't do energy mass balance, that's why yang mass flow rate ni, yang column yang row bawah ni tak payah buat dulu, because we haven't done mass balance. Mass balance we will do on report 2. Misalnya report 2, kamu akan hantar balik PFD dengan stream information table ni, tapi dalam report 2 dah ada dah mass balance punya nilai. But that's not report 2 lah. Report pertama ada stream information table, but only stream number, temperature and pressure. Sebab tu saya kata setiap stream tu kena tahu, sebab nanti you want to include in your stream information table. Okay, so this is example that is done by your senior. Okay, I take this from your senior. You can see actually, yang tadi saya tunjuk yang block diagram phosphate rock tu. Sorry, yang block diagram phosphate rock tu, yang saya tunjuk block diagram, akhirnya ni yang PFD yang dia keluarkan daripada block diagram tu. Okay, so this one also I would say a little already quite, taklah complex. This is actually quite easy dah lah sebenarnya. So as I told you, I did not expect you to do complex one. Bukanlah I did not expect you to do a complex one. Because you have to be very realistic. Yang penting untuk saya dalam design project is, first of all, you know how the process of your, that what you want to produce. Let's say phenol, proses memastikan phenol tu kamu kena faham. Kamu kena tahu apa main equipment dia, function of the main equipment, the flow to the main equipment, the utilities you need to use for the main equipment, the mass balance, energy balance. Okay, so I will not restrict you. If you want to do a more complex one, so much better. But my advice, normally I will ask my student limit lah equipment dalam 10 to 15 equipment termasuk utility. Dalam ni ada berapa? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12, about 10 to 15, normally about 10 to 15. Kalau dalam 10 to 15 equipment, stream number kamu akan ada dalam 20 kepada 30 stream number. Kamu kena faham, 20 ke 30 stream number means setiap stream tu ada mass balance dia tau. So you imagine, if let's say you have stream number 40 ke 50, how are you going to do the mass balance? It become too complex. I did not advise you to do so, but if you want, okay je, I will help you to do it. Okay, so normally that's my guideline. Equipment 10 to 15, the most equipment sometimes goes to 20. Streamline not more than 30. 20 to 30 streamline is already good enough for me. Okay, so that's on the chapter 4, block and process flow diagram. But we are not finished yet. I want to finish another chapter. As I told you, bukan saya nak rushing, tapi saya kena habiskan. So make sure kamu dah boleh start on your